I'm late recording for Kira. Oh. All right, you guys, what's my U? DV. And how do I make that decision? Sin x doesn't get simpler when I take its derivative. Everybody good? So du equals 2 dx. V equals negative cosine x dx. Oh wait, just negative cosine x. And this was sine x dx. I'd turn those into positives. How are we feeling? All right. I got one more. We're going to integrate the integral of x cosecant squared x dx. Thoughts? We're going to let u equal x, and we're going to let dv equal cosecant squared x dx. Why am I doing that? What do I know about cosecant squared? It's very similar to secant squared, right? And secant squared is the integral of secant squared is tangent. So the integral of cosecant squared is, you're really darn close, negative cotangent x. And du is dx. So uv becomes negative x cotangent x minus the integral of negative cotangent x dx. And again, I would immediately make those both positive so I don't lose track of my negative signs. Y'all, what is the integral of cotangent? We can't do a u sub here. If we need to, we could think of cotangent as cosine x over sine x, right? And from there, if I let u equal sine x, du would equal cosine x dx. Right, so this is the integral of 1 over u du, which is ln of u, which is ln of sine x. Now, that being said, I would say the integral of tangent, secant, all of those kinds of things, those are rules that we learned in 1151. They're on that blue sheet I gave you the other day, except for those of you who weren't here the other day when I gave you these. It's third period?
Yeah. Oh, I didn't think you had a third period.
I do.
Oh, sorry.
It's first, second, and sixth are the ones I don't have.
Second, okay.
Everybody good? How are we feeling about USUB?
USUB or integration of parts?
Yes.
Good.
I mean, integration by parts is really U sub on steroids, right? Like it's the same conceptual things, except for now it's just, it's like a double UV sub kind of thing.
I have to be conscious about differentiating my U's and V's now.
Yes.
Yeah, I have to rewrite all of my D's.
So, but like, what about what you are integrating would you be looking for? You're looking for the product of two different functions, and U sub doesn't work. I mean, it's because again, this whole unit
Right. Yeah.
is going to be about different integration strategies. So like one of the things we want to start thinking through is what integration strategies do we want to use? Okay, is everybody with me so far? All right. I'd like to talk. I'm going to give you guys time to do your homework, but I want to talk about one more concept of review that'll become kind of imperative with what we start tomorrow. Okay, everybody good? And so what I'd like to do is talk about my 3 favorite trig identities, which are all the same trig identities. What do I know about sine squared theta plus cosine squared theta equals 1?
Rearrange that however you want.
If I divide everything by sine squared, I get 1 plus what's cosine squared over sine squared would be, cotangent squared theta. And then 1 over sine squared theta would be cosecant squared theta. Everybody good? Likewise, if I divided that whole thing by cosine squared, I would have tangent squared theta plus 1 equals secant squared theta. Is everybody good? So we will be using all 3 of these, mostly these 2, a lot tomorrow. So like we will be pretty much all of tomorrow will be some sort of manipulation of these. So I want us to be very, very, very comfortable with these identities. And if you don't know these identities right now, make sure you do by tomorrow, right? Like those are very studyable. Also, I think, Riley, you didn't get one of these, and Alec, you didn't get one of these. But I did talk about them in the video. So you can't use them on any assessments, but as we're practicing, these are some reminders of some integral rules that we have, okay?